This is problem 6. This is another empirical formula problem, but this time we're going to discuss a different aspect of empirical formula. The word empirical, by definition, means experimental. We're all scientists are empiricists. We base everything upon experimental observation. So this is the experimentally observed and the experimentally obtained formula. And regrettably, in any one experiment, we can only find the relative mass percent of the different elements in a compound. We don't actually get the molecular formula directly. That is found from another experimental method. So we have to be able to combine the two. Once we know the actual molecular molar mass, well then we can get the molecular formula, but oftentimes that is not readily available. There are some instruments that do give you both, but not always. So this is a necessary problem. Again, this is going to go back to the fundamental skill of being able to convert percent to decimal fraction. A very simple task. All we need to do to convert percent to decimal fraction, we move the decimal point 2 to the left. To convert decimal fraction to percent, we move the decimal point 2 to the right. So we'll start with the given information, and we're given a mass percent, and so I know that for every 100 grams of material, since percent is by definition parts per 100, that I can use an assumed 100-gram sample. And I can get the mole ratio from that. So I'm going to assume a 100-gram sample, and that means that there is going to be 28.7 grams of chlorine, and that there is going to be 1 mole of chlorine. And we're also given the information, we're assuming that sodium has an atomic mass of 23 grams per mole, chlorine has an atomic mass of 35 grams per mole, and oxygen has an atomic mass of 16 grams per mole. So chlorine is 35 grams per mole. I've already got the mole in there. And then oxygen, there is going to be 52.5 grams of oxygen, and there is 1 mole of oxygen for every 16 grams of oxygen. And last but not least, I have 18.9 grams of sodium, and that is, there is 22 or 23, 1 mole of sodium is 23 grams of sodium. So the first part of this setup is straightforward dimensional analysis. We just have to convert from grams to moles of each of the elements, and we're assuming a 100-gram sample. And then we use percent as parts per 100, and it's a straightforward conversion. Now we'll have to dust off the scratch paper. So I'll pull up this board, and it'll be my scratch paper. And we're going to have to do some long division. Not to worry, it's a skill we all have. Sometimes we get a little rusty when we haven't done it for a while. So the good news is we're going to get plenty of practice. 0.7. Okay, now this is going to be a 0. And then it's going to be 35 is going to go into 280. Well, okay, 35, 280. I guess it's going to be somewhere around, well, 10 is 350. Subtract 70 from 350. that's going to be 270 from 350 is going to be 280. Right on. So I'll pick 8. 8 times 5 is 40. 8 times 3 is 24, and 4 is 28. Okay, so that gives us 7. Bring the 0 down. 35 goes into 72 times. So this equals 0.82 moles of chlorine. Now back to the scratch paper, and this time I have 52.5 divided by 16. Okay, 16 times 3 is 48, so and now 12 subtract 8 is 4. That is 45. So it would be 3.2. And that's going to be 3 times 16 is 32. And 5 subtract 2 is 3. And 5 subtract 2 is, so it's 130. 16 goes into 130. 10 times 16 is about 160. 160, 130, 32 times is 32. So it's going to be around 8. Actually, it's going to be around 7. I'm guessing. 7 times 6 is going to be 42. 7 times 1 is 7, and 4 is 11, 112. Oh, it's 8. Eight times 6 is 48. 8 times 1 is 128. Yeah. Okay, so that turns out to be, that's close enough. 3.28 goes in the next position. And last, we're going to have to do sodium. And that is 18.9 divided by 23. Okay, 23 goes into 18 0 times. And let's see, 23 goes into 189. Let's just try 8, see where it takes us. 8 times 3 is 24. 8 times 2 is 16, and 2 is 18. 184, so that's 5. Oh, that would be a 2. And that would be 46. And I don't care what happens after that because I have enough information to finish the problem. 0.82 moles of sodium. This has enough information to write the crude, unrefined formula, and it's going to be, recall the rules. We start with a salt. We're going to start with a metallic element first. And so we're going to start with sodium. And then this is obviously going to be some sort of an ion. And the rules give a higher priority to chlorine is more metallic than oxygen in this case. And so it's going to be NaClO. And we have got these subscripts, 0.82. Cl is 0.82 and oxygen is 3.28. Okay, that is our crude formula when we need to reduce this to the simplest whole number ratio. And so the obvious thing to do is divide everything by 0.82. And that turns out to be the only non-trivial one. These are trivial, but this one I gotta go 0.82 goes into 3.28. I gotta move the decimal point over 2. And 328 is divided by 82. Well, gee, it looks like awfully close to 4. Let's see where that takes us. 4 times 2 is 8. And 4 times 8 is 32. Oh, 4.0. So that worked out rather nicely, and therefore then the empirical formula is going to be NaClO4. And while we're at it, although it's not required explicitly in the problem, but so we can have the next part of the problem work out more effectively, I want to find out what the empirical formula weight, just for what's coming up. So I'll go empirical formula weight. Our mass is going to be 22 plus 35 plus 4 times 16. 16 times 4 is 64, plus 64. Okay, 4 is 9, 10, 11. 6 and 3 is 9, so that's 121. So 121 grams per mole is the empirical formula mass. Now, for the second part of the problem, the molecular weight is found to be 122.44 grams per mole. You'll note that that is awfully close to the formula mass. What we want to do is find out what multiple of these is going to give us the molecular mass, the molar mass. So what this reflects is experimental certainty. Okay, we have some rounding that was done in both the masses and in for the percentages. And so what we're after is N is equal to molar molecular weight over E. What we're after is some multiple, some number N, which when multiplied by the empirical formula weight is going to give us the molecular weight. And in this case, this is equal to 122.44 grams per mole divided by 121 grams per mole. And so this reflects experimental precision. This is 1. Therefore, the formula, the molecular formula is NaClO4. And just for fun, practice naming it. What would that be called? And in case you give it a second, this would be sodium. And this is one of the oxyanions, chlorine. And this is the one with the most oxygens. So this is sodium perchlorate. Okay. That's it.